So here I have a Boolean expression. First thing I want to do is just apply De Morgan's law. Just get rid of all these knots above this term here. Okay, so not x will just be x. Not or will be and. Not y will be y. Not and will be or. And not z will be not z. Now I just want to get rid of these brackets here. And we'll expand it again. Now, what I notice with this term here is there's two of the same symbols here. So there's two y's. So I just want to rearrange this just to get them together. It doesn't really make a difference, but I want to just put them together here. Y and y will just equal y. Now here, I'll just look at each term and just check to see if I've got repeating symbols here. So I can see if I remove x from these two terms here, it will leave me with not y or y. So let's do that. So not y or y will have to equal 1, because if y equals 1, not y will have to be 0. And if y equals 0, not y will have to be 1. So there's at least 1 in this little expression here. So this has to be 1. X and 1 will just be x. Sorry. So now we got this term here, and we got this term here. We can actually apply absorption law here. This will just equal x. Now I can explain this further. You probably know that the absorption law looks a bit like this. And like this as well. But actually, it doesn't matter how many terms you got this side. No matter how many terms you got in this term here, it will still equal x. And that's the same here. You can go on forever. It will still equal x. So that is why this equals x here by applying the absorption law. So first thing I want to do with this Boolean expression is just get rid of the knots here by just De Morganing it. So not w will just be w, not or will just be and not x will obviously be not x. Now I just want to focus on this little expression here inside the brackets. I can see that there's sort of repeating characters here, x and y, and there's also another x here. So I think I want to remove x and y from these two terms. Now that was perfect, as that left us with z or not z, which will equal 1. Because if z is 1, not z will be 0. And if z was 0, not z will be 1. Now, here I can see that obviously we got x and y and 1. So that will just simplify to x and y. So now inside the bracket here, we've got two terms. We've got x and y, we've got x. We can actually apply absorption law here, as you can see by this, for this thing inside the brackets. So that would just simplify to x. So we could leave this expression like this here, or we could simplify it further. This can actually be simplified to w XOR x. So it might be worth noting that if you've got something like this, let me just write it again down here in a different characters. If you've got a pattern like this, this can be simplified to a XOR b.